Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring solving systems of equations by substitution. This is part one of a two-part lesson. So in previous lessons, you learned to solve systems of equations by graphing. Graphing is sometimes not an effective method whenever you have numbers that are really big or solutions that are perhaps fraction values. So we need another way to solve that systems, and one way is substitution. We'll learn another method in future lessons. So in solving systems by substitution, let's go through some steps, and then I'll show you how to use those steps in our first example. So step one, you want to identify one of the equations that's in the form x equals or y equals. Step two, you will substitute the expression from step one into the other equation and solve. Step three, substitute the numerical value that you obtained in step two into the equation from step one, or your original equation, and solve for the other variable. Step four, write your solution as an ordered pair. And step five, you'll check your solution. Now, these steps won't make much sense until you see them worked out in practice. So let's talk about example one. It says solve each of the following by substitution. And in problem A, we have two equations. The first one is x equals negative 2y minus 5. And our second equation is 4x minus 3y equals 2. So step one says identify one of the equations that's in the form x equals or y equals. So in this problem, we're going to identify the top equation, x equals negative 2y minus 5. Okay, step two, substitute the expression from step one into the other equation. So let me write down the other equation. It's 4x minus 3y equals 2. Now, what we're going to do is we're going to replace one of these variables with parentheses. So how do you know where to put the parentheses? Well, you simply look to see which variable your original equation is solved for, and it's solved for x. So that tells me where the parentheses go. So I'm going to put 4, instead of 4x, I'm going to put 4, and then make your parenthesis really big, minus 3y equals 2. So all I'm doing is rewriting the equation, and instead of the x, I'm replacing the x with parentheses. Now I'm going to take the equation, or excuse me, not the equation, the expression from step one and plug it into that parenthesis. So I'm going to plug in negative 2y minus 5. Now step two tells us that after you've substituted that expression in, you solve the resulting equation. So we'll distribute the 4. That would be negative 8y minus 20 minus 3y equals 2. Now we'll combine any like terms. So negative 8y minus 3y gives me negative 11y minus 20 is equal to 2. Now add 20 to both sides. So negative 11y equals 2 plus 20 is 22. Now divide both sides by negative 11. So 22 divided by negative 11 is negative 2. Now let me draw a line here to separate step 3 and 4 from step 1 and 2. So in step 3, we're going to substitute the numerical value, that negative 2, into the original equation. So let's write down our original equation. It was negative 2y minus 5. Now, you're going to replace that y with parentheses and substitute in the numerical value, which was negative 2, and then solve this equation. So x equals negative 2 times negative 2, which is positive 4, minus 5. So x would equal negative 1. Now, step 4 says to write your solution as an ordered pair. So something comma something. So our x value goes first and our y value goes second. Now, in step 5, we're going to check the solution. Now, I'm going to, excuse me, I'm going to check the solution on my calculator. I'm not going to write out my check step. Your teacher may require you to write it out. If they do, then feel free to write it out. So, in my top equation, we have x is equal to negative 2y minus 5. So I'm going to put negative 2 times the value we got for y, which was also negative 2, and then minus 5. And this should equal negative 1. And it does. Okay. Now, I have to check the second equation, which is 4 parenthesis, whatever we got for x, which is negative 1, minus 3 parenthesis, whatever we got for y, which was negative 2. And this should equal positive 2. So negative 2. Whoops, I'm glad I checked it. I was supposed to put a negative 1 there. And now it checks out. All right, so I'm going to box in the solution because it checked out. All right, now let me make some space, dividing space here. Now I'm going to show you the steps again in problem B. So let me start with step 1 again. Identify one of the equations that's in the form x equals or y equals. So in this problem, it's our second equation. It's in y equals form. So I write that down. So this is my original equation. Okay. Now in step 2, you substitute this expression into the other equation. So the other equation is 3x minus 5y equals 12. I'm just going to write it down first. Okay. Now you're going to replace one of these variables with parentheses. How do you know where to put the parentheses? Well, it depends on what variable was solved for. In this case, it's y. So that tells you where to put the parentheses. So 3x minus 5, big parenthesis, is equal to 12. Now, substitute in the expression from step 1, negative 6x plus 2. All right, now we're going to solve the resulting equation, but be very careful because in this problem we're distributing a negative. So 3x, negative 5 times negative 6 is positive 30x. Negative 5 times 2 is negative 10, and that is equal to 12. Now I want to combine any like terms, so that would be 33x minus 10 is equal to 12. Now add 10 to both sides. So 33x is equal to 22. Now, when you divide both sides by 33, on your calculator, you're going to get a decimal. Never, ever, ever round a decimal. You want to write your answer as an exact answer, which means we have to put it in fraction form. So that would be 2/3. All right, let me draw a line separating step 3 and 4. So that's step 2. Now, step 3, you're going to substitute that numerical value into your original equation. So our original equation was y equals negative 6x plus 2. And then I'm going to substitute for the x. And I'm substituting in 2/3. So y equals negative 6 times 2/3 would be negative 4 plus 2. So negative 4 plus 2 is negative 2. Now step 4 is write your answer as an ordered pair. So in this problem, x was 2/3 and y was negative 2. Now I'm not going to box it in until I check it. So to check it, I'm going to go back to my original equation. 3 parenthesis 2/3 side arrow minus 5 parenthesis. Now when I plug this in, I should get 12. So negative 2, and I do. So it checks out in my first equation. Now take your second equation, negative 6 parenthesis, and plug in what you got for x, which was 2/3, plus 2, and I should get negative 2. And I did. So I'm going to box it in. All right. Now, example 2 is just a little bit different. It says, what is the value of y? So here, our answer will not be an ordered pair. They only want one of the values. In this case, they want the value of y. So I'll still follow the same steps. Step one, whoops, I want to pin. Step one, identify one of the equations that's in x equals or y equals form. So here we have an x equals form, negative 2y plus 9. Step two, write your other equation. And then substitute in the original expression. So how do you know where to put the parentheses? Well, in this case, we put it for x. So 6y plus big parenthesis equals negative 59. All right, substitute in the expression from step one, negative 2y plus 9, and solve. So here, there's nothing to distribute, so I'm going to combine like terms. So 6y minus 2y would be 4y plus 9 equals negative 59. Now subtract 9 from both sides. So negative 59 minus 9 gives me negative 68, and then divide both sides by 4. So negative 68 divided by 4 gives me negative 17. Now, let's go back to the question. What is the value of y? And we just found the value of y. So y is equal to negative 17. I don't even have to do steps 3 and 4 because it didn't want the value of x. All right, example 3, special cases. Now, there's something kind of weird that can happen whenever you're solving systems equations, and I want to show you that now. So in problem A, we have y equals negative 0.5x plus 4, and 3x plus 6y equals 24. So step 1, identify the equation in y equals form, negative 0.5x plus 4. Step 2, write down the other equation. And then we will replace the y. We'll replace the y with parentheses, not the x. So 3x plus 6, big parenthesis, equals 24. And I'll plug in negative 0.5x plus 4. So 3x, now distribute the 6. So 6 times negative 0.5x would be negative 3x. And 6 times 4 is 24 equals 24. Now 3x minus 3x is 0. So that zeroes out. And I'm left with 24 is equal to 24. So when your variables zero out, like they did in this case, and you're left with a true statement, your answer will be infinitely many solutions. Now, I'm going to show you graphically why this is happening. So let me create a graph here. Our top equation was negative 0.5x plus 4. So there's our first line. It's in green. Now, watch what happens when I graph the second line. 3x plus 6y equals 24. Do you see how it landed right on top of the line? So these are the exact same line, which means everywhere they land on each other, that is a solution. So this is infinitely many solutions. Infinitely many solutions occurs when your variable disappears and you're left with two numbers that are equal to each other. All right, problem B. We have x minus 2y equals 12 and y equals 1/2 x minus 4. So in step 1, we'll identify the y equals equation. In step 2, we'll write down the other equation. And then we'll replace the y with parentheses. make your parentheses really big. And I'm going to plug in 1/2 x minus 4. So now we'll distribute the -2. Again, be very careful when you're distributing a negative. So -2 times 1/2 x is -1x. -2 times -4 is +8, and that equals 12. So x minus x, that zeroes out, and we're left with 8 equals 12. So this time, our variables zeroed out again, but I'm left with two numbers that do not equal each other. So when that happens, your answer is no solution. Now, let me show you graphically why this system was no solution. So I'll type in my first equation, x minus 2y equals 12. So that's the black line. And then 0.5x minus 4, that's the red line. So these two lines, if we graph them, will never intersect. Therefore, there's no solution. So again, whenever your variables zero out and you're left with one number equals another number and it's false, that's no solution. So that's two special things that might occur when you're solving systems by substitution. All right. Now let's look at some real world problems. Two cell phone plans offering different text packages are outlined below. In Plan A, we have $9.25 per month, along with a charge of 6 cents per text. So I'm going to write that, an equation for that is 9.25 plus 0.06x. Plan B is $2.50 per month, along with a charge of 15 cents per text. So I'm going to write that as 2.50 plus 0.15x. And it says, for what number of texts would the two plans cost the same amount? So I want Plan A to equal Plan B. So I'm going to take the equation for Plan A, 9.25 plus 0.06x, and make it equal to Plan B, which was $2.50 plus 0.15x. And I'm going to solve this equation by getting all the variables on one side and all the numbers on the other. So let's start with the variables. 0.1, I'm going to subtract 0.15x. Now make sure you put that 0.15 under the 0.06. You want to keep your like terms together. So this would be $9.25 and 0.06 minus 0.15 is negative 0.09x, and that's equal to $2.50. Now I'm going to subtract the $9.25 from both sides, and that would give me negative 0.09x equals 2.50 minus 9.25, negative $6.75. Now divide both sides by negative 0.09. So negative 6.75 divided by negative 0.09, and that gives me 75 texts. Now, I'm not going to box that in till I check my answer. So my first equation was 9.25 plus 0.06 times 75, and that'd be 1375. Now let's see what it would be, what the cost would be for the other equation. 2.5 plus 0.15 times 75 texts. And sure enough, the plans would have an equal cost when there are 75 texts. So now I can plug or box in my answer, excuse me. All right, the perimeter of a rectangular garden is 46 feet. The length of the garden is 5 feet more than twice the width. Find the dimensions of the garden. Now, one thing you need to remember here from previous courses is that the perimeter formula is 2L plus 2w. Okay? Now, let me draw a picture of what's happening here. If this is the width of our rectangular garden, then the length is 5 feet more than twice the width. Now, I always put the variable first, so 2w, and then 5 more than that would be plus 5. Now, to write this as a system of equations, my first equation would be P equals 2L plus 2W. My second equation, oh, excuse me, they told me what the perimeter was. Ooh, let me erase that. Let me go back and highlight the information that I should have. It says the perimeter of a rectangular garden is 46 feet. So my first equation would be 2L plus 2W equals 46. Now my second equation can be obtained from this information. The length is 5 feet more than twice the width. So I'm going to say length equals 2W plus 5. Now I'm going to follow my steps. In step 1, I'm going to identify the variable that's by itself. So L equals 2W plus 5. In step 2, I'll write down the other equation. And then I'll replace the L with parentheses. And into the parentheses, I'll substitute the expression in from step 1, which is 2W plus 5. So distribute. 2 times 2W is 4W. 2 times 5 is 10, plus 2W oh, I made a mistake here. This was supposed to say equals 46. So plus 2W equals 46. Now combine like terms. 6W plus 10 equals 46. Subtract 10 to get 6W equals 36 and divide by 6. And that gives me a width of 6. So in step 3, I'll write down my original equation, L equals 2W plus 5. And then I'll replace the W with parentheses and plug in my numerical value, which was 6. So length equals 12 plus 5. So length equals 17. So this is a 6 by 17 rectangle. Now, here's how I'm going to check that. I'm going to put 17, 17, 6, and 6, and then add that up. 6 plus 17 plus 17. And it does give me a perimeter of 46, which is what the original problem said. So this is a 6 by 17 rectangle. And that concludes today's lesson, Solving by Substitution Part 1.